Hey, welcome to our channel. I'm Geetanjali, your math coach, and today we are going to learn Algebraic Expressions Part 1. In this video, we will learn basics of algebraic expression, its various components, like and unlike terms, and types of algebraic expressions. Before starting, you must know what is algebra. Algebra is a lot like arithmetic. It follows all the rules of arithmetic and it uses same four main operations that arithmetic is built on, and those operations are plus, minus, multiplication, division. It's not limited to this. Anything which you can do in arithmetic in a similar manner you can do in algebra as well. Then what is the difference in algebra and arithmetic? Difference lies here. Algebra introduces a new element, the element of unknown or variable, which is any letter in alphabet, that is A, B, C, D, any of these letters you can see which are used for the variable, but most commonly used variable is X. You must know a few more definitions. One of them is constant. A constant has a fixed value. For example, any number you can take. It may be a positive number, it may be a negative number, it may be 0. Its value doesn't change. Wherever you use these numbers, its value doesn't change. So these are called constants. Other thing is variable. Variable is any letter or symbol that represents some unknown value, or you can say variable can take various values. Its value is not fixed. How it works? For example, if you write x equals to 2, here value of x is 2, because when you will put 2 on the left side, then only this equation will become balanced. So here value of x is 2. But in the second example, value of x is 65. 55 plus 10 will give you 65, so value of x will be 65. So here in first example it is 2, in second example it is 65, whereas in third example it is 25. 100 divided by 4 will give you 25. So everywhere, wherever you have used it, its value is totally depend on the context. It totally depends on which purpose you are using, where you are using. Accordingly, its value will be determined. It doesn't have any fixed value. But of course, whenever you write 2, its value will be 2 everywhere, wherever you use it. So that this 2 is a constant. But this x is not a constant. Its value will depend on the context where you are using it. So this is known as variable. Now finally, algebraic expression. An expression that contains numbers, operators, and one or more variables is called algebraic expression. For example, x divided by 5, 2y plus 3. These are very simple algebraic expressions which I have taken here just to explain you how it looked like. Here you can see there is a variable, there is a constant, there is operator. Here also this is constant, variable, operator, and then again constant. Here constant is multiplied with the variable in this term, whereas this is only a constant. So this can be formed in many ways actually. So a few things which you need to remember while solving an algebraic expression or talking about algebraic expression. One of the thing is there is no equal sign in expression. If you put an equal sign, it becomes an equation. It's not an expression. Like here 3x plus 5 equals to 10. This is an equation. This is not an expression. Yes, of course, only if left side, if you take only left side, then that was an expression. But since you have put an equal sign and you have written something on the right side of it, it has become an equation. It's not an expression. 3 plus 7. This is not an algebraic expression because it doesn't contain a variable. There is no variable, only constants are involved here and operators. So this is a numerical expression, not an algebraic expression. Now let's see components of expression very closely. For example, I have taken an expression 2x plus 3. Here this x is a variable and this 2 is coefficient of x. This plus is an operator, this 3 is a constant, and if you see before plus sign there is 2x, this is your term 1, and after plus sign there is 3, that is your second term. So you have already seen what is variable, you know what is constant, you know what is operator. We need to look closely about coefficient, term 1 and term 2, or in short we need to look closely about terms also. So let's look at them one by one. Now terms. The expressions we deal with have parts which are formed separately and then added. Such parts of expression which are formed separately first and then added are known as terms, or the terms of algebraic expressions are separated by plus or minus sign. For example, I have taken this expression. It is 4x square minus 3xy. So if you see, there is a negative sign. So the part which is before this is a different term and the part which is after this is a different term. We can say this expression has two terms. One is 4x square and other is minus 3xy. Although you can take second term is separated by negative sign, but I would suggest you take any term along with its sign, because later on while solving any questions it will be really helpful for you to consider sign along with. So here we are considering first term is 4x square and the second term is minus 3xy. So these are the terms, first term and second term. Now if we talk about the first term is 4x square. So 4x square is actually product of 4x and x. These are the factors of this term. So we have formed it separately. Similarly, the second term is the product of minus 3x and y. When we multiply this, we get the second term. So what we have done, we have formed these terms separately and then added them to get this expression 4x square minus 3xy. Take one more example. 13 minus y plus 5y square. Now this is our expression. You see, first minus has come, then there is plus sign. It means there are how many terms? 1, 2 and 3. So this expression has 3 terms. First is 13, second is minus y and third is 5y square. So these are the 3 terms of this expression. Now let's talk about each term separately. So when we say first term, it is 13. This is just a constant. It is not multiplied with anything. This is just a constant. But if you see the next term, it is minus y. Minus y, actually we can get minus y by multiplying minus 1 with y. So this term we have got by multiplying minus 1 with y. Now the third term, it is 5y square. So we have multiplied 5y and y. 2 y's and 1 5 are multiplied to get 5y square. These are the factors. Factors of the third term is 5y and y. So what we have done, these 3 terms 13 minus y and 5y square are added to form our expression 13 minus y plus 5y square. I hope you must have understood the concept of terms. What are the terms in an expression? It is an important concept. You must understand this properly. Now the coefficient. Numerical coefficient or coefficient. The numerical factor of the term is said to be the numerical coefficient or simply coefficient of the term. In previous example, we have already understood what is the factor of a term. Let's see. In the given example, 2x square minus 5xy. You can see there are 2 terms. First is 2x square and the second is minus 5xy. Now in the first expression, you can see that it has 3 factors, 2, x and x. So its numerical factor is 2. So 2 is the numerical coefficient, or in general we call this coefficient of the term 2x square. Now in the second term, we have minus 5x and y. So minus 5 is the numerical coefficient or the coefficient of the term minus 5xy, because rest 2 things are variables. So this is in general called the coefficient or numerical coefficient. One more example. 13 minus y plus 5y square. Now it has got 3 terms. First term is 13, second term is minus y and third term is 5y square. So in the first term, it's a constant. There is no coefficient. In the second term, we have a variable. Its coefficient, as I told you, that minus 1 is multiplied to y to get minus y. So when you multiply these two, you get minus y. So its numerical coefficient is minus 1. Now in the term 3, 5 is numerical coefficient or coefficient of y square in the term 5y square. Sometimes you will see the word coefficient is used in more general way. previously we have seen those were the numerical coefficient, but sometimes you may need to work differently on coefficients. So let's see. We say that in term 2xy, suppose I'm taking a term 2xy. In this term 2xy, I can read it in many ways, or I can define its coefficient in many ways. First of them can be 2 is the coefficient of xy. Okay. Second way, maybe I take x. Now x is the coefficient of 2y. Now I can take y. So y is the coefficient of 2x, you can say. Let's take one more example. Suppose we have 4p square q as a term. Now in this we can say 4 is the coefficient of p square q. Or we can say p square is the coefficient of 4q. We can also say that q is the coefficient of 4p square. So this concept is a little bit different. You may come across this many times. This is more general way. A coefficient may be either a numerical factor or an algebraic factor or product of two or more factors. It is said to be the coefficient of the product of the remaining factors. For example, when we took 4, so it was the coefficient of remaining factor p square q. When we took p square, it was the coefficient of remaining factors 4q. So this way you can find coefficient. But whenever we talk generally about coefficient, it's the numerical factors which we talk about. So identify the terms, coefficients and constant term in the following examples. The examples are given here. Here we have to identify a number of terms. What are those terms, their coefficients and constant term. So in the first example, we can see that this is a plus sign, and before this plus sign there is one term, and after this plus sign there is a constant. So terms here are, first term is 5x and the second term is 12. Now coefficients. For x, you can see the coefficient of x is 5. This is the variable x and its coefficient is 5. Therefore coefficient of x is equals to 5. Now constant term is that term where you don't have any variable. Here this 12, along with this there is no variable, so this is your constant term. In the second example, there are two terms, 12 and 10c. So terms here are 12 and 10c. There is plus sign between these two, so these are two terms. Now coefficients. To check coefficients, we have to find out where there is variable. In this term we have variable c, so coefficient of c is equals to 10 here, and the constant term is 12. Again here the constant term is 12. Now let's take third example. In this example the terms are z square and minus 9z. These two are separated by minus sign. So here the terms are z square, and I told you take the terms along with its sign. So z square and minus 9z are the terms. Coefficients, here we have z square. When nothing is multiplied to the variable, we consider that 1 is multiplied to this. So coefficient of z square is equals to 1. And in the second term we have minus 9z. So here coefficient of z is equals to minus 9. So here we have two terms which has variables. So we have got two coefficients, one for z square and other is for z. Now the constant term, there is no constant term because there is no term which consists of only constants. Now let's take the fourth example. In this example we have 15 plus 3w plus half. So you can see this is a constant, this is a constant. So we will not consider that it has three terms. We can add these constants. So we will consider that first term is 3w and the other term is sum of these two. When you add 15 with half, you get 15 and a half. So our expression can be written as 3w plus 15 and a half. Now the terms are 3w and 15 and a half. These are its two terms. Now coefficient of w is equals to 3. So we have got its coefficient also. Now the constant term, Here 15.5 is the only number written over here. So 15.5 is the constant term. Now what are the coefficient of x in the following expressions? These are the examples. We have to find coefficients of x. So in the first example, we see that 4 is multiplied with x. So coefficient of x is 4. 4 is coefficient of x in first example. In second example, we have x here along with negative sign. How do you get this? This is actually minus 1 times x. This gives you minus x. So x is multiplied with minus 1. Therefore, coefficient of x in this case is minus 1. In this example, we see y square x. So what is multiplied with x? It is y square. So coefficient of x in this case is y square. Now the last one, here you can see x plus y plus 5x. Here it looks like there are 3 terms, but actually these two are like terms. We'll study the concept of like terms later. But for now, I can tell you when you have same variable, you can add the coefficients of that. So here it is 5 plus 1. So it will be 6x plus y. This expression is actually 6x plus y. So coefficient of x in this case is equals to 6. Now the like terms, as I told you in previous example, what are like terms? The terms which have same algebraic factors are like terms, or like terms are the terms which have same variables and same matching exponents. The order of the variables does not matter. So now same algebraic factors. What are the algebraic factors? Those variables which are in each term. Those variables are known as its algebraic factors. So if any two terms have same, two or more than two terms, if those have same algebraic factors, then those are known as like terms. Here it is important that not only the same variable, their exponent should also be equal. For example, in this we have to identify which are like terms. So 2xy and 15xy, 2xy minus 3x, 4y minus 19y, and 5 examples are given. We start with the first example. Here we have 2xy and 5xy. Are these like terms? So what is our condition? Same algebraic factors, and they should have matching exponents. So here algebraic factors are x and y, and here also algebraic factors are x and y, and their exponents is 1. In both cases, we don't consider constants in this case. We don't consider their numerical coefficient. Only the algebraic factors. If they are equal, then the terms are like term. So these two are like terms. So we can say these two are like terms. Here the variables are x, y, and here the variable is only x. There is a difference. One variable is missing over here. So these are not like terms. Now here y, 4y and minus 19y. We are concerned only about these variables. These variables y and y. So these are they have same algebraic factors. So these are like terms. Now 7x cube and 7x square. Although they have same variable x and x, but here it is cube and here it is square. Those should be equal to make it a like term. Since they are different, although the base is same, that is fine, but since the exponents are different, these are not like terms. Now next, 4x square y cube and 7y cube x square. Look here, you have x, you have x, you have y, and the exponent of x is 2. Here also exponent of x is 2. Here exponent of y is 3. Here also exponent of y is 3. So what we consider, they should have same variable and the variable must have same exponent. It is there. It doesn't matter in what order they are written. It is fine, absolutely fine. So these are like terms. As we have learned about like terms, let's look at unlike terms. So unlike terms are two or more terms that are not like terms. That is, they do not have the same variables or powers. The order of the variable does not matter here also. For example, we have to identify which are the unlike terms. I think you must have understood the definition. All those terms which are not like comes in the category of unlike terms. So let's see these examples. In first example, 16x and 16y. Constants are same, but these variables are different. So these are unlike terms. That's true, these are unlike terms. And here variable is xy and here variable is only x. So these are unlike terms, these are not like. Here 4y minus 19y, variables are same, variables are same. So these are not unlike terms, these are actually like terms. And here variables are same but their exponents, here you see exponents are different, exponents of the variables are different, therefore they are unlike terms. Here x square y cubed, x cubed y square. X and y, both the variables are there in both the cases, but here exponent of x is 2, whereas here exponent of x is 3. So these are unlike terms. I've taken a few more examples. In these, expressions are made by like terms and few are made by unlike terms. Observe them once again. For example, here these examples, all these examples, these are the expressions now. As there are plus or minus sign, 2 or more terms are there. So these have become expressions now. But this expression is formed by 2xy and 15xy. We see that this xy and this xy. So these are two like terms. So this expression is made up of like terms. Same here, ABC for ABC minus 10ABC. So this expression is made of like terms. Here also same variables, like terms. Here same variables with same exponent, although the order has been changed. Here x square has come first, here y cube has come first. That is absolutely fine. You just have to check their variables along with their exponents. It should be same. So this expression is formed by two like terms. Similarly here x cubed and x cubed. Since these two are same, so these two are like terms. So this expression is formed by like terms. Now next is unlike term. You can see this expression is formed by two terms. First term contains xy, second term contains zy. You must be observing that I am not worried about this 2 or 15. I am not at all worried about these numbers because we are talking about like terms and unlike terms. It totally depends on the variables involved. So here xy and here zy. So these are unlike terms. So this expression is formed by two unlike terms. Here 4abc minus 10ab square c. Although we have abc at both the places, but here b is squared. This is important. This is important that the exponent is not same in both the cases. So these two are unlike terms. Here the variable is y, here the variable is z. So this expression is formed by two different variables. So this is formed by two unlike terms. Here xy, that's fine, but here x squared and here x cubed. Here y cubed and y squared. These are unlike. So exponents are different, therefore these two are unlike term and this expression is formed by two unlike terms. Here one term contains a variable whereas the other term is a constant. So these two are unlike terms. So this expression is formed by two unlike term. So this is just to explain you how you can find out like term, unlike term and everything. But whenever you come across the expression, it will be a combination of like and unlike terms. It's not like that the complete expression will be formed by like terms only or by unlike terms only. It would be a combination of both. I hope you must have understood what is the like term and unlike term. It is an important concept. Now next is type of algebraic expression. Based on the number of terms in an algebraic expression, it can be divided into the following types, and those types are monomials, binomials, trinomials and polynomials. So what is monomials? An expression with only one term is called a monomial. For example, these expressions. It has only one term, this also has only one term, this also has only one term. See, you can see 15 into x into y. This forms one term. There is no plus or minus sign in between. So this is only one term. So this is a monomial. Here minus 3 into x. That form one term. So this expression has only one term. Therefore, this is also a monomial. Similarly, this one 7x cube is a monomial. Now we talk about binomials. An expression which contains two unlike terms is called a binomial. So in these examples, you can say 15xy minus 3x. First example here, 15xy and minus, there is a minus sign. It means this is first term and this is second term. You have already seen that. So this expression consists of two terms. So this is called binomial. Similarly here it is 3x square plus 5x. So this plus sign is there. So this is your first term and this is your second term. So there are two terms. So this is also called binomial. Here also a square minus b square. This is one negative sign. Before this is first term and this is second term. So this also consists of two terms. This is also formed by two terms. So it will be called binomial. Let's see what is trinomial. You must have guessed what is trinomial. The expression which contains three unlike terms is called trinomial. Yeah, here one more important thing I forgot to tell you. These should be unlike terms. Those two terms should not be like terms. Similarly with the trinomial, those should be unlike terms. So here 15xy minus 3x plus 10, you can see all these are unlike, and this is minus sign, this is plus sign. So before this first term, then second term and third term, we have three terms. So this is trinomial. Here again minus sign plus sign separated. So this is first term, second term and third term. So this is also a trinomial. Here also a square plus b square plus ab plus sign plus sign. So this is first term, this is second term, this is third term. So there are three terms. So it is called trinomial. Now the polynomials. In general, an expression with more than one terms with non-negative integral exponents of variable is called a polynomial. It means any expression, any algebraic expression which consists of two or more than two terms. But here the important condition is that the exponent of the variable should be non-negative integer. So here you can see in these examples 15xy minus 3x plus 2y minus 4z minus 10. There are 5 terms and we have different variables, and you can see all the exponents are non-negative exponents. So this is a polynomial. Here in these examples also, even these will come in the category of polynomials. This also consists of 4 terms and this is also called polynomial. So that's all for today. Here I have written summary, basics of algebraic expression. I have explained you so many things about the expression. These are the parts of expression which you must know before moving on to the next session. In the next session, I am going to take addition, subtraction, multiplication, division and many more operations which you can perform on the expression. Those I will cover in coming sessions. So that's all for today. If you have any queries or ideas that you would like us to present, please leave the comment below. Check out our other videos as well. Thank you so much for watching, and if you like it, please don't forget to subscribe.